Okay, we're looking at the 10.3C practice quiz today. The problem says a random sample of 1,100 teenagers ages 12 to 17 were asked whether they played games online, and 775 said that they did. So from this initial information, we can get our sample size n, and we can get p and q. P is the probability of people who responded positively, which would be 775 over 1,100. And then Q would be 1,100 minus 775, which is 325 over 1,100. So that's just some basic information we can get off the beginning of this problem. The first question says that we need to construct and interpret a 99% confidence interval for the population proportion P, and we need to follow the inference toolbox. And keep in mind, even if they don't say that you need to follow the inference toolbox, whenever you're doing a confidence interval, you still need to follow it. So whether or not it's said, you still need to follow these 4 steps. The first step, the parameter. What do you want to find by doing this inference toolbox? You want to find the true population proportion P of all the teenagers ages 12 to 17 who play games online. Second step, conditions. There's 3 conditions: SRS, normality, and independence. For the SRS condition, we're told that it's a random sample, but we're not necessarily told that it's a simple random sample. So we're going to proceed with caution. For the normality, they don't say that our sample is from a normal distribution, so we have to check NP and NQ and make sure they're bigger than 10. And for NP, we get 775, and NQ, we get 325, and obviously both of those numbers are much larger than 10. Therefore, we can assume normality for this population. And independence, the way you check independence is that the population size needs to be at least 10 times the sample. The sample was 1,100, 10 times that was 11,000, and obviously there's at least 11,000 teens in the world, so we're allowed to assume the independence in this scenario. We're doing a confidence interval. It's a proportion, so it's a 1 proportion Z confidence interval. Step 3, the calculations. The formula, you want to write that first: p hat plus or minus z star times the square root of p hat q hat over n. We're going to list how we calculate stuff. P hat is 775 over 1,100, which is 0.705, and q hat is just 1 minus this value. You'll see later I got 0.295 when I did that. For my confidence interval of 99%, the z star value, this is one of those things you're supposed to memorize from 10.1, is 2.576. So just plugging in our data, we'd have 0.705 plus or minus 2.576 times the square root of 0.705 times 0.295 over the sample size 1,100. And when you do that, you will get the interval of 0.6696 to 0.7404. That's our lower bound, 0.6696, upper bound, 0.7404. Our step 4 interpretation. We're just going to say that we're 99% confident that the true proportion of teens who play games online is between 0.6696 and 0.7404, which conceptually means this is about 67%. So we're confident that the true proportion who play games online is between 67% and 74% of all teens. Question 2, how large a sample would you need to estimate P within 2% at 99% confidence? So the formula for error estimation, and they don't say the word error in here ever, but when you're estimating it within a certain level, that means error. Your error formula is the error is greater than or equal to z star times the square root of p hat q hat over n. The error level that we're given is 2%, which is 0.02, and then we're using the same values up here from step 3 in the calculations of problem 1. Just doing some basic algebra. We're going to divide each side by 2.576. We're going to square both sides. We're going to cross multiply. When you eventually do all that, you will end up with 3450.188, and n needs to be at least that number. So again, we're going to round up to the next whole number. Your final answer, the sample needs to be at least 3,451 people, or teens, or whatever. Question 3. Suppose that the results of the survey were used to construct a separate 99% confidence intervals for boys and girls. Would the margins of error for these 2 confidence intervals be the same as, larger than, or smaller than that for the interval you constructed in question 1? Justify your answer. So the basic concept here is we're looking at the same 1,100 person sample, and if we break those 1,100 people into boys and girls, we're basically guaranteed some of them are going to be boys and some of them are going to be girls. There's no way that we're going to take 1,100 people randomly and end up with all boys or all girls. So when we split this up by gender, each of the samples is going to be smaller than 1,100. And whenever you have smaller samples, the error amount is larger, because if you have a smaller thing that you're dividing by, this whole number becomes larger when the denominator is smaller. And if this is larger, when we go back up here, when this stuff is larger, that means a larger amount that we're adding or subtracting from our p-hat, which makes the width of the confidence interval larger. So that means the error amount is larger. And the reason for that, again, is because the sample size is smaller. Question 4. Explain how the estimate obtained from the survey could have been affected by response bias. So the key here is, well, not the key, but conceptually, there's lots of potentially correct answers. So my answer is just one potentially correct answer. But if we're interviewing teenagers to see whether or not they play games online, it's entirely possible that they're going to give a different answer based on who can hear their answer. So I just said, kids are fickle beings. They'll give a different answer based on who can hear them. If their friends are around, maybe the kid is going to say, oh, of course I play, because they want to, it's socially acceptable to play video games among your friends. But if their parents are around, maybe the kid's going to say, oh, of course I don't play video games, because their parent maybe doesn't want them to, wants them to be doing homework, wants them to be taking care of siblings or working or something else. And they're not going to admit that they play, and that would lower the proportion who said that they did play games. So those are different forms of response bias that could have affected the survey results. And there's other things you could come up with. As long as they're plausible and you give a good explanation, you would earn the points for this question. Okay, that's the whole 10.3c practice quiz.